Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we want to present about our assignment, rapid prototype and reverse engineering. We are from group Wednesday 4. Our product is offset part from CATPAT Katia V5. I am Ali Hanifah bin Amran from MTM.
Oh, I'm Muhammad Firdaus bin Muhammad Filus. I'm from MTM also.
My name is Robiatul Adawiyah binti Amran from MTM.
Okay, so we go through the part that we have finished. Firstly, first step is we go to the tools in SolidWorks. We go to the add-ins, and then we go to the scan to 3D, then click the OK. And then go to open file. Quick filter is you can search the preferred file, which is the Katia V5 part. Then we go to the file location. Offset part. So we go to the process, and then it may take a few minutes to progress. Okay. Okay, I think I want to pass to Rubiatul to explain the long process, part 1 until part 4. Can you, Rubiatul?
Okay. So I will proceed this presentation with part 1. Okay, the first step in reverse engineering a part is to capture the data from the existing part. Depending on the material and size of the part or facility, a variety of different scanning equipment can be utilized. The design process of the mechanical component involves 3D scanning and laser scanning that deals with creating a point cloud. The STL data that can be used to manipulate and turn the feature into surface that can be used. Step by step using tools given. First, turn on Scan 3D to save it as a file. Second, select the units that will be used in this design process. Third, to manipulate the feature, turn on 3D scan to get the tools needed as this process deals with a third-party scanner, which there is PLY file that was saved out from its proprietary program. Fourth, STL section is used to trim, remove extra data which is not needed and simplify the STL. STL edit is used to move, rotate, scale and locate the feature. The curve is used to extrapolate curvature information from the STL. The surface is used to create a surface. There are two main options that can be used. First, automatic creation, which is automatically go through and create patch of the surface based on the STL edit that have been done. Second, guided creation, which is to create a closed fit surface and produce a better result in the end of the process. 8. Deviation analysis is used to take closer look at the resulting information. Next, part 2, the STL edit. First, it is very important to focus on areas selected of the scanning. Use areas selected that have a good clean scan and information that can be used to create a 3D part. Select STL edit and make sure to notice the number in the dialog box as it is having important value because it is dealing with the number of polygon faces to create the STL. Use select reference, select the origin in any point, select X direction, Y direction, while Z direction is automatically pointing out. Noise removal is information that is floating out in space. Noise can be removed by area if the area at a large part or small part is different than the main part. By turning the removal corridor all the way up, it's taken anything that was below the main part of the STL edit. Next section is the extraneous data removal. Just rotate the part and only focus on the area selected. For creating surface, the automatic creation is the best choice in creating the area selected, while guided creation is going to be quite a bit more work in order. Then, by using polygon selection, remove all the unnecessary information and make sure to have some overlap extra area. Next, use the simplification, which means reducing the STL edit size to remove unnecessary information to get a smaller size. Smoothing is the section that decides whether simplification is needed or otherwise. Rotate the part to get a good view. Use the global slider to remove some of the frequency that was added by the scanning process. Use the slide bar to the boundary to smooth out the boundary as much as possible. Use the local smoothness if there is a hole or bad geometry. Just manually cut out the unnecessary information around it. Then deselect that option and save the file. Next, part 3, the curve wizard. The curve creates boundary and section curves in point cloud and STL files. Select a pair of points, a plane, or an existing curve. Use reverse direction if necessary to switch the direction in which the section curves are created. Selecting a pair of points defines a vector. The software creates intermediate section planes perpendicular to the vector starting from the selected point on start plane. Adjust curve fitting tolerance. Move the slider to the left to sample more vertices or points, making the curve fit more tightly to the STL edit or cloud. Move it to the right to loosen the curve fit. Add points that refine the curve position. Select the STL vertices to add curve defining points. Adds and displays breakpoints on the curve where two curves connect. You can see the connectivity at breakpoints to be contact, tangent, or smooth and trim to the curve selected. Next, part 4, automatic creation. First, select automatic creation. After the patches for the STL edit is produced, there is a surface error option, which means it cannot produce a patch for that area. The feature lines can be manually modified and re-update the preview and move to another position. A good resulting surface can be obtained by choosing option to relax the feature lines. Choose add feature line from points between the points so that a new feature line can be created. It gives new areas for these patterns to be built. And then go back to STL edit to remove any unnecessary information for the final result to be much better. That's all for my part. I will pass to Firdaus.
Okay, I will continue with the part 5, which is the surface wizard by using guided creation. For the surface guided creation, surface wizard is used to create surface. There are two main options that can be used, which is automatic creation and guided creation. So first, we need to select the guided creation. This option is necessary for symmetrical model. First, we go through the face identification process, and then we can choose whether the manual painting option is used. And in this process, by using manual tool given, any color can be selected and it can be manually start printing. Trace the edge of the surface to make a single surface out of the edge. It is completely separated from the rest of other surface, and it is automatically created a different color for the inside surface of the model. Then we can use this extraction option, which is we can extract all the surface according to the separated color surface. Then we extrapolated that information so that it can figure out how the surface can be created. Next, part 6 is trim and blend. Trim tool is used to remove unnecessary material and cut everything away from all the surfaces. By creating pocket geometry, it can be detected that the color painted during guided creation process were blended together. Create a boundary surface so that everything will look very smooth. And the next is the part 7, which is finalized surface. Basically, in this part, it is important to use front plane to trim all the unnecessary information based on the direction that have been used. We add the line at some point at the surface and create the tangency from the line added and remove the unnecessary information. So from there, we can see that the tangency can be added to the surface. And the next one is the part 8, which is in contact design. For this part, we need to design a part that is going to hold a camera in one of any part that is stable to be diffuser pocket. It is for the demo camera to show the back view or to view the functionality. We need to decide whether we need the part just to be functional or need to be aesthetic. When we start designing the part from scratch, it has been to basing them around the origin. So all the standard front, top and right planes to really simplify the modeling process. I will pass to Ali for the next part.
Okay, for the part 9, with the surfaces, in this part, we can create some geometry that will actually fill the entire pocket. And then all the unnecessary surface need to be trimmed so that the funky geometry will not appear. Rule surface option can be used to produce a sweep going toward a plane. For the part 10, multi-body operation, using the combine feature with the subtract option, the body to combine disappear as it becomes observed in the feature. To create a copy of the body, the move or copy feature will be used. In this part, a holder for camera needs to be sketched by adding some geometry to the part. There are parts that need be split and combined in this multi-body operation. And then part 11, which is the final design and export. First, create a relief so that the entire middle section can flex as the camera is inserted. Then do the section view. This section view, okay? And take a look at what happened and make sure to delete all the operation that has error and continue to modify manually. Correctly converting CAD file into STL file is very important in order to print accurate parts. An STL file is a triangulated approximation of a 3D CAD model. In SolidWorks, simply go to File and then Save As from the window. So we can choose the type of the STL file. Then we click the option. So we can adjust the tolerance, which is the resolution. Clicking the option button will bring up the following window. For the best result, output as binary and set resolution to fine. Okay. This setting will suffice for most parts, but in some cases, it will be necessary to use a custom resolution to increase the number of triangle users. So I will show you the 3 result, which is 3 different of the resolution. Okay, this is the normal resolution. So we can see that the resolution on the scale of surface. Next, I will show you the another fine graphic. Okay, this is the fine graphic, which is different, small different. like the resolution will be accurate. We can compare the resolution of the surface. And then the last is custom, which is high resolution. Okay, this is high resolution and custom, which is the tolerance I put in 5°. So you can see the surface. Okay, so this is our result. The conclusion is reverse engineering is general transformation approach to transform various products and artifacts from lower level representation to higher level representation, directly related to learning and understanding of facts, products, processes, and artifacts. Process of new knowledge discovery can be also conceived of as re-engineering process or extending previous knowledge. Re-engineering is the way for obtaining know-how or knowledge which can be used for many purposes, including better software maintenance. Software reverse engineering is a new research area among software maintenance. It includes activities of understanding the system and recovery into from system. Program understanding is the most important subset of reverse engineering. Discovery of abstraction is key issues. Okay, thank you so much for watching.